This lesson is 2.3.2, Evaluating Materials. In this lesson, we will focus on how we can select an appropriate material for our project or task. First, let's take a look at how we can compare properties. Scientists and engineers investigate materials through observation and experimentation. When choosing a material to use, the properties of materials should be compared and evaluated for use in a specific application. Designers have to consider trade-offs. For instance, choosing a material with a greater strength may mean the final product has less flexibility or may cost more. For most properties, you can use a measurement or parameter of the property for comparison. During the design process, designers make many decisions. One critical decision involves selecting the materials for the construction of a prototype or final product. A fantastic design will fail to perform if the appropriate material is not selected. So how do we decide? The selection of materials is primarily dictated by the following factors: cost, manufacturability, sustainability, impact on the environment, safety of the material, mechanical and other physical properties, durability or wear of materials, and corrosion or chemical properties. One material selection approach that an engineer or designer might use is to first identify an ideal class of material, such as metal, ceramics, polymers, or composites. Then, an engineer can narrow down the search for an appropriate material to the variety of metal, for example, that best fits the design criteria and constraint. Another material selection approach is to first consider how the product might be manufactured. Then, a material is selected to meet both the design requirements and the limitations of the available manufacturing process. The figure on the next slide illustrates this process. As you can see, beginning on the left, we begin with prospective materials. We then decide if those prospective materials meet necessary material specifications. Any rejected materials are removed from the process. The materials that have the necessary properties move on and are then analyzed to see if they are functional, manufacturable, durable, or if they're too expensive. We then remove any materials that don't meet this criteria and move on with the feasible materials. We then take those feasible materials and compare and rank them to then determine which material would be best. Engineers tend to be conservative in their choice of materials, often selecting well-known and well-tested materials for a given application. This strategy provides material choices that are reliable, with property and performance data that is easily found. But newer, emerging materials may offer the greatest opportunity for innovation.